Hello and good day everyone. Today I'm going to show you how to solve a word problem each for indefinite integrals of basic calculus using the derivative formula and simple linear regression for statistics and probability. So let's dive right in. So let's put this into practice by solving an example. We have the function of 4x cubed minus 8x squared plus 7 dx. To find its antiderivative, we'll use the power rule for integration. Now let's remember that the formula for the power rule is the antiderivative of xn dx is equals to xn, it's supposed to be exponent, xn plus 1 over n plus 1 plus c. Here is our formula. Now, according to the power rule, when integrating a term with the form xn, we increase the exponent by 1, according here, and then divide by the new exponent here. We basically just copy the exponent here to below the x. Now let's apply this rule to each term in our function. So using the power rule, we're going to start with our first term, which is 4x cubed, and it's going to be looking something like this. So the antiderivative of 4x cubed dx is equals to 4x cubed plus 1 over 3 plus 1. So it's going to be looking at this. Then after that, we're just going to add the exponent plus 1. So it's going to be equals to 4x to the power of the 4th over 4. So now we are going to simplify this by dividing the x with our denominator. So it's going to be 4 divided by 4 is equals to 1, so that will only leave our x. Then let's copy our exponent. Then, of course, we should not forget the plus c. So the antiderivative of our first term is x to the power of the 4th plus c. So we have found the antiderivative of the first two terms. So let's go to the last term, which is the plus 7. So since it's only a constant term, what we're going to do is basically we're just going to add the variables. So the antiderivative will be 7x plus c. So now that we have all our antiderivative terms, we're going to be adding all of them. So it's going to be equals to the derivative of 4x cubed minus 8x squared plus 7 dx is going to be equals to ax to the power of 4th minus 8 over 3x cubed plus 7x plus, of course, we should never forget, plus c. So basically, this is the antiderivative of the polynomial function using the power rule. So that was the example. So always remember the formula for the power rule, and that the plus c represents the constant of integration, which accounts for all possible antiderivatives of the given function. So now let's apply what we learned to solve a real world problem using the antiderivative formula, the power rule. So now let's apply what we've learned to solve a real world problem using the antiderivative formula of the power rule. So a car's velocity is given by the function vt equals 2t squared minus 4t plus 5, where t represents time in seconds. Find the equation for the car's position. To find the position of the equation, we need to integrate the velocity function vt. Let's now apply the antiderivative formula we just learned. So basically, this is the polynomial function where we need to find the derivative of. Similar to what we did earlier, we're just gonna find the antiderivative of each of these terms using the power rule. So what we're gonna do is first find the antiderivative of the first term, which is 2t squared. So basically 2t, so 2t squared plus 1 over 2 plus 1 is basically equal to just 2t squared over 3. 2t cubed over 3. So simplifying this, we are just gonna get 2 divided by 3 is gonna be 2 over 3. Then copy the variable and the exponent, t cubed. So this is going to be the exponent of the antiderivative of our first term, 2 over 3 t cubed. So now that we have found the antiderivative of our first term, let's copy that. It's going to be 3t cubed minus now let's find the antiderivative of our 4t. So this basically has one exponent 1. So 4t 1 plus 1 over 1 plus 1 is just going to be equals to 4t cubed over 2. So simplifying this, we're going to be 4 divided by 2, it's going to be equals 2. Then copy the variable and the exponent, t squared. So now we have found our second antiderivative, which is 2t squared. So copy here, we have negative 2t squared. Sorry, 2t squared. So now on to our last term, which is the 5. So what I just said earlier, basically just add a variable, so it's going to be x. Then let's add our constant, which is c. So this is basically the equation and the answer to our word problem. Combining these results, basically, I just said, this is the position equation, which represents the car's displacement. 2 over 3 t cubed minus 2t squared plus 5/6 plus c. And there you have it. We've covered the basics of one of the basics of indefinite integrals and demonstrated how to solve a word problem using the antiderivative formula of the power rule. So if you keep practicing, and soon you'll be integrating functions like pro. So to simple linear regression, it is a statistical method used to understand the relationship between two variables. And now we're gonna solve a real-life world problem for this lesson. So we have a random sample of 10 drivers insured with a company. We collected data on their driving experiences in years and monthly auto insurance premium. Here's the table. So here is the table. The driving experiences in years is the X value, and the monthly auto insurance premiums is the Y value. Our goal is to find the simple linear regression equation, since it's gonna be too long if we do if we solve all of these. So we're just gonna find the simple linear equation for this problem. To accomplish this, we'll use the simple linear regression, which aims to lift a straight line to the data points in a way that minimizes the overall distance between the line and the actual observations. So the equation of a straight line is y equals mx plus b, m times x plus b, where m is the slope, while b is the y-intercept. We'll use the statistical formulas to find these values. So first, what we need to do is, from the table, we're gonna find the sum of the x and the y values. Then we're gonna calculate x times y values, then its sum, as well as the x squared value, and find its sum also. Now here is again our table. Now we're gonna calculate. I'm just gonna hurry this up. I'm gonna calculate the x times y values. I'm gonna put them here. Then the x squared values, I'm gonna put them on here. So I'll see you in a second. So as we can see here, this is the result, and I've already calculated the x times y value and the x squared values. So now I'm gonna sum all of the these values for each column. So now, as you can see, I have calculated all the values. So this symbol represents the sum of the sum. So I just found the sum of the x value, which is 71. I calculated, Then the sum of the y value, which is 148. Then the sum of the x times y value, which is 37,159, and the sum of the x squared values, which is 657. And now we are gonna find the needed values to find for this equation. So using these values, we can calculate for the m, the slope, and then the b, the y-intercept, to find the equation for the simple regression, linear regression. So first, we have a formula using these values to be able to find the slope. So as you can see, first we're gonna solve for the slope. So we're gonna use these formula. So I'm just gonna input it real quick, and then I'm gonna solve it. So after substituting the values, some of the values on the formula for the slope, I have found that the slope is approximately negative 0.923. And now I'm gonna find the value for the y-intercept, or b, using this formula. We have the sum of y minus the slope times the sum of x over n. So now I'm gonna quickly input all my values to this formula. So now a few seconds after I've inputted the value, I found that the value of the b or y-intercept is exactly, or approximately, 20.255. With this value, now I can make the line regression equation. So using these values, we can now find our line equation for our word problem, which is our goal. So y is equals to m, or slope, the negative 0.923, x, or driving experience, plus b, or our y-intercept, 20.255. So, there you have it. That's our equation. And so we now have our equation. So that's all. So that's all for my video. Thank you for listening, and ciao.